All right. Good evening, everybody. Dr. B here. It is Tuesday at 8:30, so we're back on for a little bit. Tonight, we're going to look at functional groups. So we're really going to focus on this idea in organic chemistry, and you'll see this in general chemistry a good bit too. These very characteristic groups that help you identify what type of compound it is and also how it's going to react with other ones. So I see some folks here. Say hi in the chat so I know who's around. Yeah. And we're still on my new computer, which I'm enjoying. It feels a lot faster, a lot easier for me to work, and I have my 3 monitors up, so it should be fun tonight. Let's see what we got here. Isabella's there. Awesome. Good to see you, Isabella. Excellent. Shepalonius. Excellent. Excellent. Nice to see you. So why don't we do this? We'll start out and we'll look at some functional groups, do some practice, and then we'll try this app thing that I've been building and see what's going on there. And maybe we'll take a look here at our big map and let me get it up on the screen here. There it is, and see who's using our app. Already 4 people are on the app, but we'll do that later. All right, and yeah, let's do that. So let me shift over to this here. All right. Hi, Lilac and Lola. And something official. I like that. Something official. All right. So these are your common functional groups. And these are probably the ones I would recommend that you really make sure you can do. There are a lot of other ones, but these are the big ones you'll see in organic chemistry. So what we'll do is we'll go and try to figure out what some actual compounds look like, what functional groups they have. So take a moment and figure out in this compound here, and this is the same thing, what functional groups do we have? And there's Loretta. Hey, Loretta, good to see you. Awesome. So I'm going to circle the functional group that you're trying to figure out here. Right here. And these are all carbons right here. So put that in the chat if you figure that one out. What is the functional group we're looking at right here? This one comes up all the time. I see Isabella has alcohol there, and that's right. So that's our alcohol, this OH group. So if you think of like ethanol, it'll always end in OL. That tells you you have OH. And you got to be careful because it's an OH bonded to a carbon. If you have something like NaOH, this is a metal. So this would be an ionic compound, sodium hydroxide. It has to be bonded to that carbon. And that's what the R means here. There's a carbon with some more carbons on it. All right, let's try another one. So that one's not too bad, but you'll see this on a test. They'll say identify the functional group in this compound. This one's a little bit harder. So here's your compound. I'm going to put this right over top of it, kind of like an overlay. And because the molecular geometry isn't always the same as we have here, this carbon is this one here. So here's your 1, 2, 3 carbons, like that. It's a little tricky. You have this group here, but then you have all of that here. Close, Isabella. It's not an aldehyde though, because an aldehyde, where's our aldehyde? That doesn't have an OH here. See, the aldehydes just end in H, but we end in OH after the carbon there. And it's not an alcohol because we have the double bond up here. So it's not an aldehyde. So see if we can match the pattern. Something official says, yeah, you have a carbonyl group. This is your carbonyl group. So it is carboxylic acid. So this is propionic acid, prop for 3. And you add that OIC on the end. And because of it, it's a very polar molecule because oxygens are electronegative. This molecule dissolve in water, and this H right here, that can come off and be, that's what makes an acid. So if the H comes off, you get H+, and that's why it's an acid. but it's really weak because the H doesn't come off very much. That's our carboxylic acid. All right. So you can see the patterns, and once you know the patterns, you can just apply them to any of these organic molecules. This one might be a little bit more difficult because of the way it's represented. And give it a try. I'm going to write the carbons in for you. So I have a carbon here, 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 and here. So you can see them. And there's the double bond right there that we're seeing. What type of functional group do we have? So we're looking for something that has the double bond. And these, when we have just the other carbon backbone, we don't consider this the functional group. This is our backbone here. It is indeed that double bond right here. That's what we have on the end. And there would be a hydrogens off of this here. So it is an alkene. So Isabel, you got it. Shepalonius, you're close. Aldehyde does have a double bond, but it's to that oxygen. All right, from India, Dr. Rapula Kumar, welcome, welcome. Great to have you here. Okay, so let's take a look at the app for a second that I was talking about earlier. It's kind of interesting. So I've been trying to. I like doing videos, and they're helpful, but they're a little passive. Sometimes you just sit and watch. So I'm trying to build this web application or a web tool to help people learn. And I'll put it over here and show it to you. And if you look in the, what do you call it, chat, there's a link pinned to the top so you can go and see this. In fact, I wonder who's there. There are 6 people there, and I can see even where they're at. There's someone from, where's this at? Louisville. 2 people from Indiana, someone from Jacksonville Beach. I wonder if that might be Andy. Someone in South America. Anybody else over here? Anybody in India? Oh, my map's too big. Nobody from India. That surprises me. Anyway, so it's kind of cool. I can see who's here on the app. And now I lost where the app was. ChemApp. So I just put this functional groups thing here on for us. And so it's just flashcards right now. So you can go there and look at this and what functional group do we have here? And so you can think, well, it's all single bonds, it's all hydrogens, and then we have carbons bonded to other carbons. That's an alkane. And then because I'm still learning to program this, the next question's way down here. And you can just keep going through. Here's one we just had. Has that double bonded oxygen and the hydrogen. Who should know that one? Shepalonius, you should know that one. Hey, Andy, good to see you. And Ramana is here. Excellent. Good morning, Ramana, I think, for you, right? So you can just go through this app, and it keeps going through. And you can, this is our carboxylic acid because of the double bond with the OH. You can just keep going through the app and practice. Sometimes it gives you a duplicate, and so on. So that's out there. That's pinned in the chat, and I'll leave that up. You can use that anytime you want. And if you go back here, there's also polyatomic ions and then alkanes. So hopefully I'll build all this. And if you want, you can give me feedback here on the forum, and that'll help me do a better job with it. All right, let's go over. There's 8 people on the app now. There's someone from India. Chennai, excellent. Okay, let's do some more over here on this. See if you can figure out what, if you could figure out, there's 2 groups on this compound, 2 functional groups. Hey, Stefano, good to have you there. Great to have you as a member of my channel as well. That's always appreciated. Yeah, Hamza, I remember. All right. So I'll circle the, I'll write the carbons in for you. So you need to get used to where these carbons are. This is one of the functional groups you should identify. And then this here, that's the whole other functional group that we're dealing with here. So let's call this 1 and call this 2. See if we can figure out what they are. One of them you have to look down here. So it's helpful to know that carbon always bonds to 4 things, or I should say it always has 4 bonds. So this carbon here would have hydrogens. This would have 2, and this has 1, 2, 3, so just 1 here. So you can figure out where all of the hydrogens are here as well. So that's good to know. And this CH3 group right here, that's one of the functional groups you're looking for. CH3, that's your methyl group. Anybody know what the other one is? You guys are usually faster with this stuff. Okay. So we have a carbon, double bonded oxygen, and carbon. So you could consider these carbons with other carbons, double bonded. That's your ketone. Not to be confused with this ester here, which has carbon and then double bond, and then kind of like our carboxylic acid, but more carbons out here. So it takes a while to get used to this chart here. Isabella, you're right, it is a ketone. I like ketones. I don't know. I like the symmetry of having the double bonds with carbons. I guess as a chemist, I like symmetry. All right. Let's move up and do another one. Whoops, that didn't work. Here we go. Oh, well, I guess it doesn't matter if it has the name there. This is ethyl acetate. Give it a try. Contrast G, you've been studying functional groups and nomenclature all day. You know, organic chemistry, so much of it is just learning how to name things. Because if you can't figure out functional groups, you can't name things. And if you can't name things, you're given a question on an exam and they might expect you to draw the structure from the name and you'll be lost. So this is a real core kind of thing that you should be able to do. And I'm trying to actually put more naming into the app I just showed everybody a minute ago, which is, you can get the link at the top of the stream. So you start counting your carbons. In this one, it kind of doesn't matter, but you want to start counting your carbons from the end that'll give you the lowest numbers when you name it. Because realistically, these molecules, they move in 3 dimensions. So there isn't really a left or right, because you could just spin it around. When you name, you start to get the lowest numbers. All right, it is an ester. I see a lot of people saying ester, ester, ester. There was a lady when I grew up, lived across the street, named Esther. So I always think of her when I do this. So when we look at it, we have our carbon here. There's our double bond, and there's that oxygen, and it's bonded to another carbon. So I guess I should conclude, if it's an ester, I should include this carbon here. Actually, the whole thing is the functional. It is the simplest ester that there is, I guess. And you can see how it lines up over top, just like that. Yeah, ethyl acetate. All right, let's try another one. How do I do that? There we go. Oh, I'm going to hide the name for that one. Okay, give this one a try. All right. Hey, Pavel, where do I start counting the carbons? And this one doesn't matter because it's symmetrical. But if I had something like C, oop, Judy Penny wants something. Okay, like this, I would start from this side because the substituent is over here, because I want the numbers to be as low as I can. That's the way to think about it. Okay, Pavel says ether. Is he right? So an ether should have some carbons and then more carbons. And Corey, you're saying ether, absolute zero. Hey, good to see you. Absolute zero. You could call it methyl methoxide too, I believe. I'm kind of an old school chemist, but I think that's the correct name. Yeah, so ether would be a carbon. Where's the ether? Carbon, oxygen, carbon. And the key thing is these are single bonds here. So yeah, there's your ether. And you can see it goes right over top. You got your single bonds here. Good stuff, ether. All right. Let's do a few on the app over here. Actually, let's see where we are with our app here. There are still 8 people. There's no one from Africa. I used to live in Africa, so I wish there were some folks from there. A lot of people from the U.S. I think this must be maybe Andy, you're down there in Florida. We got Clarendon. That's me in North Bethesda. So yeah, and I can also see that people like are doing the different things that they're doing when they're on the page. It's kind of cool. All right, here's the app. Functional groups. So identify the functional group here. See if you can figure that one out. And Pavel, see which way you should number that. See if you can figure out numbering that since you were asking. Iowa. You know, my wife is from Iowa. I've been to Iowa a bunch, right outside Des Moines, little town called Dana, Iowa. It is cold in Iowa. It's cold here in D.C. There's snow, but Iowa, it's been brutal. That's what I understand. Like, I don't know how cold, but really scary cold. Stay warm. Alcohol, that would help you stay warm. Absolute zero, it is an alcohol, you're right, because we have this OH. And if I was to name it, I would have 1, 2, 3, 4, 5, 6. So I would call it 1, 2, 3 hexanol or hexen 3 all. I wouldn't call it 1, 2, 3, 4. I'd rather have 1, 2, 3 lower numbers. All right. In Michigan, is Michigan colder than Iowa? I wonder if the people in Michigan and Iowa, do they get along? I'm sure Michigan's really cold. And you could call this a hydroxyl group, Dexter. Alcohol and hydroxyl are kind of used interchangeably. Alcohol, but hydroxyl would be okay too. You guys should be really quick on this one. You don't have the chart now, though. That makes it a lot harder. So that's kind of good. I'll put the chart up on this website too here for if you go back and want to use that. I'll give you a minute on this one. We may have to go back and look at the chart. So remember, we have carbons, double bonded oxygen, and the OH group. So if we go back to our chart, what do we got? Carbon with a double bond, OR, that's not it. It was OH. So it looks like that's a carboxylic acid. So Dexter, you got it, absolute zero. You guys are all doing great with that. So let's check our answer here. Carboxylic acid. I really got to figure out how to move this button up closer. What about this one? This one we haven't seen tonight. COOH. Yeah, Dexter, that COOH, when you see that in a molecule, when you see that in a formula, they're talking about that carboxylic acid. And that H on the end, that's what's going to make it an acid. That'll give you the proton. That'll come off and make something acidic. But it's kind of weak. It's a weak acid. Doesn't always come off. Doesn't often come off even. All right. I'm seeing alkyne, I'm seeing YNE linkage, but that kind of gave it away here. So yeah, let's go back to our table. And right here is your alkyne. And when you have 3 of these bonds, it's actually a shorter bond. This makes this kind of a shorter bond. You're sometimes asked that. And these are a number of carbons here. All right, not bad, not bad. Okay, this one's a little bit This one almost tricked me at first. I'm going to hide the name there. Give this a try, and I'm going to go look at my map and see if anybody's on the app here. There are, it says 9 people. Lots of people from the, I think probably with the US, it's because of the time zone a little bit too. One person from India. Okay. So let's go take a look at this. I'm seeing aldehyde, sp, yep, absolute zero, you're right. That triple bond would be sp hybridization. So here, when you're looking at this, you have this carbon here linked to a carbon. Sometimes it helps to draw it. And then you see the carbon double bonded, that carbonyl group, and it's just a hydrogen. If it was OH, it'd be a carboxylic acid, but here it's just a H, and that makes it our aldehyde here. Carbon, carbonyl group, and then hydrogen. So yeah, aldehyde, that is what it is. All right, let's do one more, and then we'll go to the map, and we'll see how many people we can get on our map at once. There's nothing there. Okay, oh, we got a ring here. That's fun. So YouTube doesn't like it, Absolute Zero, when you use 2 apps at once. I would imagine that. It does. YouTube does a lot of wonky stuff like that. So maybe after the stream, you give it a try. There's on that page for the app, there's a survey form to give me feedback. And occasionally I'll choose someone at random and Zoom with them for a half hour just about the app or talk with them. Yeah, fill that format if you like. I talked to 2 folks today. It was a lot of fun. I enjoyed it. Yeah. So give this a try here. This is the name, and the ONE kind of gives it away a little bit, part of it. So this right here, carbon, carbon, oops, carbon here, and these are all carbons. There's a carbon. And we have 1, 2, 3. So carbon will make 4 bonds. So we have 1, 2 bonds, 3 bonds, 4 bonds. So there'd be an H on each one of these too. Just something good to be aware of. So we look for our pattern here. And the pattern that best matches that. And you could just see the ONE and match that, I guess. That's a ketone right here. So it can even have a big benzene ring, aromatic ring on it. Doesn't matter there. A benzylic ketone. Yeah, yep, those are all, you guys are getting a little advanced on me. So let's go over and see our map here. I don't know why. It's like being an evil genius. You have your map up on the wall and you look at everything. So there are 11 people. So in the chat, if you go up to the top of the chat, I pinned the link. See if we can get 15 people here. That would be very interesting. But everybody's from the US. San Jose. I've only been to California once. Clarendon. Where is Clarendon at? Can't quite tell. Is that Texas? Is that you, Loretta? 11. All right, we'll go back to this. I think some people like Absolute Zero were saying have problems with the phone there. Kind of makes it a little bit difficult. Okay. I don't know how many more of these I have. Oh, this one's kind of fun. Give this one a try. See if you can identify the functional group here. And then we'll talk about why it's dotted here instead of the other way with the lines. All right. Isabella, you're right. You were referring to the earlier one, I think. Because I can tell it's pretty delayed tonight. It's more delayed than usual tonight. Oh, we have 16 people now. 16 people on the map. Someone from Frankfurt. I was in an airport once in Frankfurt, but that's the only time I've been to Germany. I used to live in Spain for a little while. We used to have India. 16 people. That's a new record for me. I've never had 16 people using my app at once. That's pretty exciting. Okay, so back to chemistry. We have a carbon here, and a hydrogen. So kind of, it helps to circle them like that, or we got our carbons here, kind of circle them like that to help you to see what you have there. So that definitely is going to be, and you can see it even has the word in it, benzaldehyde, or the IUPAC name is benzene carbaaldehyde. It is indeed an aldehyde. So absolute zero, Dexter, you guys got it. Oh, yeah, that's interesting, Loretta, that it's not showing that you're on from Houston. Yeah, it's kind of, sometimes it puts weird things up there. Sometimes your ISP it'll kind of block your location a little bit. Yeah. All right. So this one definitely is going to be an aldehyde. Do I have any more of these? Ooh, I like this one. So this one is probably the last one because it's a little more challenging. This is vitamin C. It reminds me kind of like a lunar lander, like something like this would land on the moon and then reach out and grab a sample. I don't know. Maybe I've been doing too much chemistry today. So there are a good number of groups on here. We'll focus on, let's focus on these here. What are these? If you can figure out. There's a bunch of them. And my question for you is, are these the same thing too? Is the HO and the OH the same thing or different? Kind of a trick question in a way, but give it a try. Yeah, an absolute zero. I meant to mention that the dots are that aromaticity, or you could say it's kind of a resonance or delocalization of electrons. G love, excellent. Alcohols, but is this one the same as this one? Because there's a little bit of a difference here in terms of this way it's shown. They're trying to show you in 3D because here everything's flat, but it has a shape to it. So these are kind of going back into the page. This is kind of flat. So it's one way to show that. Yeah, plain, right? You got it. And again, Pablo, you're right. You could call these hydroxyl groups as well. So they're all the same functional group, a little bit different pointed, this one here. All right, vitamin C. I'm looking at this. I have a carbon, oxygen, carbon double bond, carbon OH. So I'm not quite sure how I would really simply characterize this one. So I'll leave you to think about that. You're right, G. One's going back in the plane. 4 alcohols. So absolute zero is some information. 4 alcohols, an ester, an alkene. 2 alcohols are enols, and the other hydroxyls are just regular alcohols. So you can see once you start getting bigger molecules, it gets a little complicated, but you have the tools, I think, to do the basic stuff, at least pass general chemistry. Oh, I guess I have one more here. I was going to go over to the app, but let's give this a try. This one isn't on my chart, but it does come up a bunch. So see if you can figure out, it's an amine. See if you can figure out if it's a primary, secondary, or tertiary amine. That's the challenge. That is a challenge. Let me think about it. Carbon right there. Okay. What type of amine do we have? Math. Second degree amine, but we wouldn't call it I don't think we would call it, we could call it a second degree amine, but yeah, definitely want to make sure, especially on tests. Secondary, because when we have R1, you could call this here, say R1 1 and this R2. And the R is always going to be a carbon. It means carbons. And then up here is that H up here. So that's definitely secondary amine. Hello, Abdullah. All right, so now you know secondary amines as well. Always good to know. I guess I was really ambitious this afternoon here. This is glucose, which is kind of a complicated molecule in a way because it intraconverts between these two forms. One's a chain and one's a ring, and it happens really quickly. Kind of involved, but see if you can find some of the functional groups here on our beta-D glucopyranose. That sounds like something clever to say. So let's just work on this one here. Let's not do the ring one here. Let's find the functional groups here in this one. There are a lot of them. A lot of them are the same. So this here, OH, OH, OH. So OH, you guys should be really good at already. That's the alcohol. So those are all alcohols. But what is the carbon-carbon? What is this guy up here? And this is the type of thing like you would see on a test. They would say, identify the functional group here, and they might have it circled. Absolute Zero, do you know this stuff, or are you going to Wikipedia? 4 chiral carbons, and you get into chirality too. The xanthomers are complicated, and that's getting kind of advanced into organic chemistry. You'd be kind of deep into the course, or maybe a little more advanced course, getting too heavy into that. So, Pavel, you're on my level here with the carbon-carbon, double bond oxygen. That's going to be our aldehyde, and these are all the alcohols. You know the stuff. Awesome. That's awesome. I have not taught organic chemistry a long time, much outside of the kind of the first year organic chemistry. So typically I don't end up having to teach the stuff that you're showing there. So you may be more of an expert than I am in this, which is awesome. Keep me honest. All right. So I think that's the last one. There's our aldehyde here. Oh, I guess not. I was really ambitious. Okay. I'm going to hide this. So what functional groups do we have here? There's actually a bunch of them here. Oops, I just turned it upside down somehow. That's not good. All right, so carbon, 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 and then the OH group. So again, if you circle them, sometimes that is helpful, although it gets a little messy with this one here because there's a bunch of stuff. So I would agree. This here has 2 of the hydrogens, just 1 carbon. So in that case, 2 hydrogens and 1 carbon, that will be a primary amine. Over here, you have carbon, carbon, the double bond. This right here, we know that's our carboxylic acid because we have the OH carbon double bond and the rest of the molecule. And then over here, this is a good one. I would put this on a test and ask someone to figure out what these 3 were. That would be a good way to tell if you knew it. That's got to be a hydrogen, carbon, carbon double bond. That is an aldehyde. All right. I think it is. I think you're right, Dexter. I think that is true. I have to look that up. Glutamaldehyde, carboxylic acid, primary amine. Yep. So why don't we do this? I'm going to jump back over to the app thing for a moment. It's on Breslin.org. That's my website. And then it's just called Chem App right now. And I'm hoping that I can just build out a lot of stuff for organic chemistry. And like with the alkanes here, what I'd like to do is have flashcards, right, where you can practice. Like alkanes generally have something boiling points. And that something would be low boiling points, because they don't really have any polar molecules. They don't stick together, so they easily boil. So you could go through and do practice for naming, 4 carbons, what it's called. And then you could actually take a practice thing where you answer stuff in name structures, and then there'd be like a test where it keeps score for you. So I'm hoping to build a lot more of these. But if you have a chance, take a look, and it's just a short feedback form here. Be real helpful for me to help build it, make it better, make it more useful for you, and make more people want to use it. So yeah, let's check the map. 16, we're almost to our record. A lot of you folks are either sticking around or sometimes it keeps people here after they leave. Hey, someone's from Belize City. I had a friend that used to live in Belize. He said it was a beautiful, beautiful place. I never got there myself. Maybe one day. Yeah, so Dexter, fill that survey out with your email there, and Absolute Zero, you might do it too. You seem to have some really good organic skills like Dexter. That'd be cool. I'd appreciate that. And like I say, today I Zoomed with 2 folks from Florida and from Turkey. And it's just always I always learn something I don't expect about what I'm trying to do and how I teach and all that. So it's fun. It's fun to talk to different folks. But I think I'm going to wrap it up here this evening, and we'll be back next Tuesday, do some more of this stuff. Nepal is another really pretty country. Lots of mountains there. Hey, thanks, Absolute Zero. I appreciate that. Yeah, so I feel like it's kind of weird. It's kind of weird to be like in my house, like in my office at home, and talking to people in Nepal and Texas and Frankfurt and Belize, all these different places. Kind of, 10 years ago, 15 years ago, you just couldn't do that. That was like almost science fiction. Now here we are doing that. Folks out in Iowa and Michigan, try to stay warm, because it's going to be brutal tonight. Down here where I'm at, it's going to be 12 Fahrenheit. So I'm not sure what that is in Celsius off the top of my head. Really cold though. Cool. All right. Well, this is Dr. B. I'm going to go, I don't know, maybe I'll go name some complicated organic compounds and go to bed. As always, I appreciate everybody coming out and taking part in my stream. I will talk to you in the near future. This is Dr. B, and as always, thanks for watching.